Now let us understand the basics of matrix algebra. Before addition and subtraction, we must understand the equality. Whenever we say two matrices are equal, then there are two things. First is order must be same. For two equal matrices, number of rows as well as number of columns must be same. Then Aij must be equal to Bij for every I and j. That is, each element in the same location must be equal. Let us take an example. Suppose we have a matrix whose elements are 2, 3, 4, 5. And we have another matrix whose elements are 2, 3, 4, 6. Here both the matrices have order 2 cross 2. So first condition is satisfied. Let us check the each element. Here we have 2, here also we have 2. On the second location we have 3, here also we have 3. Here we have 4, here also we have 4. But here we have 5 and here we have 6. Hence the second condition is not satisfied because all the elements should be equal. That is, each element in the same location must be equal. Hence, these two matrices are not equal. Equality does not hold here. So this can be directly observed. If each element in both the matrices is equal, then it is equal matrix. Otherwise, it is not. Now let us move to the addition and subtraction of the matrix. As equality is defined element-wise, similarly, addition and subtraction is performed element-wise. How? First, let us talk about addition. For addition, again the first condition is order must be same. Let us suppose we have a first matrix A whose element is Aij and the order is m cross n. And we have second matrix, let us say B, whose element is Bij and the order is m cross n. Okay. So order must be same in order to perform addition of two matrices. Now let us say matrix C is taken as A plus B. Then it will be actually Aij plus Bij. And the order will be same, that is m cross n. For performing addition, simply what you will do, you will add the corresponding elements. Okay. Let us take an example. Let us say suppose matrix A is 1, 3, 5, 7 and its order is 2 cross 2. And let us say matrix B is 2, 3, 1, 2 and the order is 2 cross 2. Then the matrix C will be, what you will do is simply add the corresponding element. What you will get? 3, 6, 6, 9. How? 1 plus 2, 3. 3 plus 3, 6. 6. 5 plus 1, 6. So we get 6 here. 7 plus 2, 9. So what we are doing is adding each element individually. So that is how we perform matrix addition. But what about subtraction? Let us say C is equals to A minus B. It can be written as A plus of minus B. I can write like this. Now in place of A, what I will write? 1, 3, 5, 7 because value of A is this matrix. And what about minus B? I will multiply this matrix with minus 1. Okay. So we will get minus 2, minus 3, minus 1, minus 2. Now add the individual elements. You will get 1 minus 2 minus 1, 3 minus 3 0, 5 minus 1 4, 7 minus 2 5. So that is how you perform the addition and subtraction for the matrix. Each corresponding element is added or each corresponding element are subtracted. Okay. Now what are the properties of addition? When we add two matrices, first of all it follows commutative law. What is commutative law? That is A plus B is equals to B plus A. The order in which you perform the addition, that is which matrix comes first and which comes second, does not matter. Like 1 plus 2 is equals to 2 plus 1. Okay. The second is it follows associative law. What is associative law? It means if you add three matrices, that is A plus B plus C is equals to A plus B plus C. What I mean to say is, if you add B plus C first, then add A, you will get the same result if you add A plus B first, then add C. Like in a scalar, 1 plus 9 plus 2 is equals to 1 plus 9 plus 2 is 11. So 1 plus 11 is 2, which is equals to 1 plus 9 plus 2. 1 plus 9 is 10. and plus 2. So we get the same result. That is what I'm saying. Now next is your cancellation law. That is, if I say a plus x is equals to b plus x, then I can cancel x on both the side. So what I will get? I will get a is equals to b. So this law also holds good. Is it fine? So these are some important properties which the matrix addition and subtraction follows. Okay.